All right, so in example 1, or question 1, it wanted us to determine if the lines are parallel, perpendicular, coincident, or intersecting. The only way to do that is you have to look at their slopes and their y-intercepts for each example. All right, so if we look at the first example right here, our slope here is -2 over 5, and our y-intercept is 2. In the second one, our slope is 5/2 and -7. So if we look at -2/5 and 5/2, we see that they are opposites and they are reciprocals. So that automatically, without even needing to look at the intercepts, means that they are perpendicular. All right, an example in the middle set of equations, we actually need to solve both of those for y. Okay, so that means I need to take x minus 2y equals -10, and I need to solve it for y. So that means I need to minus x to both sides. So I get -2y equals -x minus 10. And then divide by -2, and we get y equals 1 over 2x plus 5. That's the first one. So my slope here equals 1/2, and my y-intercept b equals 5. Now we're going to take -x plus 2y equals 10. And we're going to solve for y. So I'm going to add x. So I get 2y equals x plus 10. Divide by 2. So y equals 1/2 x plus 5. Hey, what do we notice? Our y slopes are the same. Y-intercepts the same. That is the definition of coincident. You have to memorize the definitions. No other way around it. Next, we got to take a look at our last set, and we got to make sure that all my fractions are reduced. 4 over 8 is not reduced, so -4 over 8 turns into -1/2. Okay, so we have -1/2 here and 1/2 down here. So if I look at both of those are the same, but my y-intercepts are different. Same slopes, different y-intercepts. That is the definition of parallel.